Hey, this is Tremor, also known as Matt Sudol, and I'm going to be going through the Pentester Labs Web for Pentester examples for testing various vulnerabilities in web applications. I'm doing this for a school assignment, St. Bonaventure University's Cybersecurity's Masters, Cyber 505, Assignment 3.1. That aside, here we are, Pentester Lab. I've got it up here on the screen, and you can get this same exercise with that URL. You will download an ISO, which is a Debian 6 image, and you just throw it into VirtualBox or VMware, fire it up, and it will give you a little web server that you can run locally, and it's got all these examples. So we're going to go through these. There's quite a few here, so let's get right to it. We're going to start with cross-site scripting, example 1. And you'll see the got a get statement in here. So what we're going to do with that get statement is we're going to get rid of hacker. We're going to test this for vulnerability by just throwing in a script, an alert, a message. We're going to say access is vulnerable. If I can type, and then finish our script tag. And this should execute. There it is. It is vulnerable. I'm going to copy that set of tags there because we're going to use this similar technique for example 2. In example 2, this won't work outright. Okay, so it's putting our text in there, so it's obviously doing something like stripping out the script tag. So we're going to first just try modifying that and say, hey, is it case sensitive? And it is not. So they are just doing lowercase script. Example 2 is vulnerable. Example 3, sticking with the same kind of concept. Is it vulnerable? Stripping out the script tag. And I know this time they're a little smarter. So they are doing no case sensitivity. They're stripping out the tag, the entire tag. Right? So what we're going to do is I'm just going to copy paste this one in from my previous attempt. And we're going to wrap the script tags in script tags. So it's going to strip out the first one here, leaving that one. And then it's going to strip this one out, leaving that one. And it is vulnerable. So it's not going through the process of like it's stripping it out with maybe a regex, find and replace, or something like that, and only doing one iteration. And the remaining string is still processed, and the remaining string has script tags in it. So example 3, vulnerable. Let's head to example 4. Now, example 4, in this case, we have hacker. If we want to just try to throw in some script tags, let's see what we've got here. An error. What is going on with this error? Just error. So we have to do a little investigation. And basically we will find is that script is being blocked. No matter how we do it, it's going through the iterations. We're not going to be able to run this through a script tag. There are other ways to execute an alert box or some JavaScript. One would be through an image. So we've got this image source, and we're just going to say Z, and we're going to use the onError attribute in JavaScript. This image isn't going to load, it doesn't exist, so it's going to throw an error, and when the error throws, we're vulnerable again, because we can do that. We can load the image through this get statement. Now, example 5 of cross-site scripting. Just another, we're going to do another method. This one, we're going to use the confirm method. So rather than an alert, so that in this example, alert is being blocked as well, right? So we're going to use a different, it's like alert, except for it's confirm. There's also prompt. And you've probably seen this too. OK, cancel, right? Prompt, I think it says OK. But there you go. Again, we were able to use the get statement to execute JavaScript. Example 6. In this one, we actually don't even have the name. It's not working. As you can see, we have this var a equals hacker is in here in the source. So what we're going to do is we're going to use that. We know that this is actually creating a variable out of this. And I am going to, basically we're going to close the variable declaration by throwing in this quote, semicolon. Then we're going to throw in an alert, because this should be the end of one JavaScript function. And then at the end, we're going to throw in just this dummy to close everything out. And there we are, vulnerable. Now you'll notice what I haven't been doing so far, and we've been getting away with it, is I haven't been URL encoding or encoding any of my special characters. You might find that depending on your browser, web server, things like spaces you may need to throw in the %20 for a space. Notice that still works. Always a good idea to encode. And there's some handy tools online if you need to. You can always throw stuff through a URL encoder. You throw in your string and it'll give you what you need to put in to the URL bar. So that was 6. Let's go to example 7. Okay, so example 7 is similar to the previous one, but this time it's stripping out special characters. We can figure that out by, let's just drop in our last one and do the page source. And you can see it's running HTML, encode HTML entities, probably on the server side in PHP, to take things like the less than, the greater than, or in the quotes, and turn them into HTML characters. So we need that not to happen. So that is where in this one, it's only blocking double quotes in this particular instance, so we're gonna switch our double quotes to single quotes. That's all we really need to do for this example. So we're gonna go in there and boop those double quotes out of there, and it's vulnerable. Okay. Example 8, cross-site scripting. Just refresh my memory on this one. It's been a little while since I've looked at it. So example 8, which is here, you actually put your name in. If we were to put hacker in, hello hacker, it's kind of echoed back into from the form. So we're gonna do this one. If we look at the source. Form action post. Best way to do this is we're just going to break the form. right? And so I've got we're going to right up here, we're going to throw a slash in at the end, and we're going to drop our script in at the end, and then HTML comment, and there you go. So we're breaking the form, adding the script, add the HTML comment to get rid of the rest of the page, and it's vulnerable. Example 9. Now this one was one of the trickier ones for me. Took me a little doing, and then I realized why it didn't work. First, we'll show you. This is just using the DOM. This is a DOM XSS attack, and you've got the tag here and hacker. So what we're going to do, we're going to probably want to do something like, we gotta fix some formatting issues on my side. We would want to do something like this. Pasted that in, and I gotta just fix that real quick. In my notes, I forgot to put my quotes in. Just fixing my notes. This will not work. You would think it would. There's a reason it won't work. And that's because I'm running Firefox. And in modern browsers have protection in place against this. So I'm going to copy this whole string. We're going to find Internet Explorer. I do not want to make this my browser. Stop asking. We're just going to drop that right in there and... oh, that's why. Silly me. HTML character encoding. I pasted it out of one URL bar and into the other, and it saved, you know, the spacing and the transformation of special characters. Well, I'll be okay. This should work. Just a moment. This is example 9. This may be a case where I need to run that through the URL encoder. Oh, I know why. Because this is DOM, and it's in the URL using the hashtag there. Just hitting enter is going to do it. I'm going to have to control refresh. Control F5. There we go. That's what fires it off. We have to reload this URL. Just hitting enter isn't enough. It's cached. So you can clear the cache, then load it, and then it runs. So there you have that. Don't have to worry about this vulnerability too much in modern browsers. But if you're using Internet Explorer, yeah, this can still be a problem. And there we are. We're done with the cross-site scripting examples in Web for Pentester. Moving on to SQL injections. These shouldn't exist anymore, ever. Bad programming if they do. But they do, unfortunately. So example 1, we're looking here. It's probably going to be a little basic. I'm going to pull up my notes. It's been a little while since I've looked at this one. So yeah, we're just going to do a simple, we've got root, and it shows ID, name, root. We want more information. We want to try to drop everybody, so we're going to give it the old or 1 equals 1, the true statement, And we're going to drop in %23, which is the pound or hashtag sign. And there we've just dropped all the tables for this particular query. Example number 2. So if we use the previous attempt, we're going to get an error. I'm just going to copy and paste in the previous attempt. Error, no space. That means is, well, just what you think it means. It's not going to let you use spaces. So let's just go and URI encode all of our spaces with tabs. That's what I did here. Those are tabs. The %09, that's the tab. Yeah, there. Example number 2. We've got all the admin root and users. SQL example number 3. And this one, instead of spaces, are tabs. If we were to play around with this for a bit, we would find that those are both blocked. So instead of those, we can also use comments. Now the comments in are these here. Those are where our spaces or tabs would go. It's basically the same query, and it is vulnerable to SQL injection. Example number 4. This is just really, really basic on this one. They're using the MySQL real escape string on the PHP side. Unfortunately, it doesn't do what the developer thought it does, and all we really need to do here is we're gonna go and get ID equals 1, and we're just gonna throw in an OR and a true statement. This is even easier than example 1. And we're giving, there we are, there's users. Example number 5. So this is similar. This is to example 4. In this case, they're using regular expressions to detect what we're doing. So if I were to try to do something similar, still works, right? So just switching to regular expressions from the MySQL escape string really did nothing. Example 6. Close example 5. So example 6, I think they're doing yep, example 6 is regular expressions again. In this case, the expression is ensuring that your parameter ID ends with a digit. So we can pretty much just do the same thing again, because it ends with a digit. Right? So those types of regular expressions to determine if the input is valid, not a great way to protect against SQL injection so far, as you can see. Example number 7. And this is the last regular expression in the SQL injection examples. This one, they're testing a little bit better for the full query, but what they haven't thought of was new lines. So we're going to start the same way, and this time we're going to inject a line fade, which is I think OA. Yeah, that's just from memory. Not even looking at my notes. Or 1 equals 1. Okay, no, I failed. Or is it 0A? Oh, 0A, not OA. Look at my notes. It's 0A. Why did I think it was OA? It's usually a number. It's hex. Why would it have been 0? Oh. Alright, take a point off because I'm stupid. Okay, ID equals 1%, 0A, or 1 equals 1. And what that's doing is that's just doing kind of a carriage return or a line break, and then evaluating the truthy statement here to do the SQL injection. It's been a while since I've done a video this long, and and my Adobe Premiere is gone, so I can't do it in little clips. I'm doing this all in one take. So SQL example 8, and I'm like, what? We're not even a quarter way through. You know what? Coffee time. The Starbucks promo. So in example 8, we've got, this is ordering, right? Order equals name. So this is probably using order by in SQL. And we just want to see if we can change the order. So we're going to drop a backtick in here and do descending. And I'm going to throw that in there, and there. We changed the order by name. We could also do order by probably age. See? And we're able to do some SQL injection here as well. And the last example. Excuse me. So in this one, we're going to inject against the request without that backtick that I used that time. And we're going to use the MySQL if statement. So it's very similar, but instead we're doing order, and we're going to use if. We'll pick a 0, name, age. There. This is very similar, just using a different approach. And that is our SQL injections. On to directory traversal. This one is fun. I love directory traversal. For this, we're going to, so if you look at these, we're going to inspect the element. And you can see image source, directory traversal example 1, file equals hacker.png. And in order to do this and retrieve the files that we're looking for, we're going to swap on over to our Kali Linux. And so on this one, I am going to let's see, it's inspect element here. Let's copy that link address. Drop it in here. Let's throw this into wget -o. There's our wget, and we are going to want to get something better than hacker.png. In this case, we're gonna go up the DOM. That should be enough, and we're gonna go for that etc.package. password. Bam. There it is. Let's do example number 2 for directory traversal. I'm going to do the same thing. Actually, don't even really need to do the same thing. If you look here, example 2, this one's var www. So we're going to, let's copy that link address. Drop it in here. Let's wget. You know, I should probably throw that in quotes. It's the proper way to do it. So in this case, they've put in var www, files, hacker. If we try to do the previous way, that won't work, but we can get rid of hacker and start from here. We're going to go up from files to www, to var, to root, to etc. Password. And there, we have just used that file include execution there. And in the third one, copy that link address. So in the third one here, this one, in the way of knowing, won't work on newer versions of PHP. We're going to wget again. Get rid of PHP file equals. So we're going to go. I want to go 3 dots. Etc. Password, and we're going to throw in a null character here. I may have goofed. Yeah, I forgot my trailing. There we go. Got my trailing quote there. Single quote. There. And the directory traversal exploits 1 through 3 using wget are done. File include is next. This one is one of my favorites. Do the most damage here, in my opinion. So we're going to do file include 1, letting us do, so basically you can see it's including page intro.php. The contents of that are obviously just hacker, or maybe all of this. It doesn't matter. We're going to use that to include, in this case, a file, a remote file from Pentester Labs. This is one in their example. It's a test include.txt. This will get processed when it's pulled in. It's basically PHP info. We just got a whole bunch of details on the website, web server, and its operating environment with the PHP info. So that's a remote file include. And example number 2. This is similar. I think we can do this. We could do this in wget, or should be able to do it in the browser. Not much different than the previous one, although they're doing some filtering. And I don't need that and page. It's easier to, and what we're doing here is we're throwing in another get statement blah equals, it's just null at the end. And there we go again. If I didn't have that, we would see that it fails this time because they're using the using this method here of, what was that method? The not sure. I'm just going to read up on that. It's been it's been a little while. Okay, they're adding a suffix to the value provided. That's what it was. If we go back, you'll see intro nothing. Whereas versus example 1, it was intro.png or .php or something like that. So in order to blank out that, that's why we added this null at the end. I hope that explains that one. Code injection. A lot of fun doing code injection. Here we are, example 1. We've got our hello hacker up and going. This is an easy one. All the first ones are kind of basic. So it's just asking, the best thing to do with the code injection vulnerability is to, if you can, call system. The way we're going to do that is we're going to get rid of hacker. Throw in double quotes there, the call the system, and then a actual command on the system. And we're going to terminate with the comments. And we just dropped such a password. Example number 2 for code injection. In this case, we've got a displaying, looks like an SQL query here by order, and in this case it's going to be done. If we play around with it, we'll determine that it's using usort or order by, and I can't remember which one this is. So order by is the SQL request, usort is the PHP function. Let me just pull up my notes on this one. You know what? It doesn't really matter because we're doing code injection. So we have the order by ID, but you know what I'm going to do is I'm going to escape out of that guy with a parenthesis and semicolon, and then the brackets. We're going to call system and our system control, and then escape with comments. In this case, you see it throws it in. It still completes the the SQL query and drops our data right in the page. We have a runtime error, but who cares? We got let's see, password again. Now this one looks like we've got some regular expressions in the get statement. So it's that's what we're gonna do. We're gonna use the global. Just, trying to remember what this example 3 was all about. It's using the preg replace PHP function with the and we're gonna add the /e modifier, right? So this multi-line regular expression, and the way that that's gonna work for us. So I'm just gonna go in here and just copying because there's a lot here. So instead of hacker here, we're going to, and we're actually going to keep all of this after that, the pattern. So I don't need that. Probably would have been faster just to type it. So system call. We're going to call a cat. It's epatsword, and then There we go. Dropping into the shell and calling a command. Obviously, we could do other things here, right? You can get a directory listing, right? You can do uname, was it plus minus a? And drop all the details. Minus plus 8, I don't know. Anything basically. You can run sed. You can run whatever's available to the user running as the web server in this case. So very dangerous stuff. And finally, example 4. In example 4, let's take a look. So if we were to let's just try to say, let's just run something here. System. Just so we can throw an error. It's always nice when you're doing this. You can play around. Let's just do ls. So we can see we've got a parse error. You get an error to throw, and you can figure out what's going on in the back end. Failure evaluating code. Assert code on line 1. So that means this is using the assert function. So in order to take example of the advantage of that, we are actually going to keep hacker in here. Boom. Drop in a single quote, and then call system within these single quotes. And we've just used a vulnerability in the assert function of PHP. Command injection. Similar to code injection and how it's going to work. So for this time, I would never suggest ever doing this, but as you can see, like, the developer has just outright given you access to a command. In this case, it's ping on the back end. You don't see it here, but you can kind of tell what they're doing. This is the console. This is the command line of the Linux system, sending you back the results of the ping. So all we have to do here is somehow escape out of there and run another command. Super easy, super dangerous. So in this case, I am using some HTML encoded ands. You'll see those should change. Oh no, that would look like, there we go, we got our etc password dumped again. It's basically what I'm doing is this and right on the command line, and then running another command. Command injection number 2. Excuse me, running out of coffee. That was the last of it, and it's cold. So I'm going to have to give myself an orbit, keep my mouth from drying up while I talk too much. Bear with me. I think we're a little more than halfway through. And what am I at? 40 minutes? Okay, example number 2 for Web for Pentester of command injection. Excuse me, I'm chewing. Okay, in this case we're going to do something similar, but instead of the ampersands, this time we're just going to drop in a line break, which is 0A in the encoder. Right there. So line breaking and then running another command. as that's your password. Example 3. So for this one, example 3, this one got a little tricky for me. And even on the Pentester lab, kind of like how you go through it. It says use Telnet or Netcat, because in the case of this one, it's not going to. The way we're doing this is we're running a redirect, the HTTP header. It's going to look a little bit like this. That's how it's going to look. Even if I pull up the Firefox developer tools and watch my network, when I do this, you see we're going to get a 302, but we're not getting the request body here. So I'm not getting the info. In this case, we're throwing in the new name, and that's a double inspect to make sure. But yeah, it's not showing up anywhere. So let's go back to Kali, and that was command injection number 3. There we are. Now I am going to come in here and do a manual proxy for Burp Suite. We have a proxy running, and I'm just going to I'm going to throw that boy to repeater. So as you can see, here we are. And then I'm going to, let's see, with IP, we're going to do pipe, uname plus minus A, and the HTTP one is already in there, so it's a redirect, and send this. And what we didn't see in our browser, we are seeing here. Next, Debian. So by all accounts, we could throw in something else here, less. There. Or executing commands on the server. Let's turn that proxy off because I may need to come back. We're done with Burp Suite for today. Okay, back to Firefox. Too many windows. LDAP attacks. We're getting down to the last one. I might be able to finish this in under an hour. 15 minutes? I think we can do it. LDAP 1. We are not authenticated, but guess what? LDAP has some serious issues. Especially, you know, Eternal Blue and the null byte. We're authenticated. Just got rid of the input. That was easy. I didn't even have to look at my notes. Alright, the next one's a little trickier though. Alright, so we're currently authenticated as hacker. We don't want to be authenticated as hacker. We can play around here with a lot of stuff to figure out how this is working. If you know LDAP a little bit, you know that the query is probably running, and we can use some regular expressions, I guess, or That's not what they're called in this case, but those dealies, right? That basically means anything starting with ADM. And as we know from some of the earlier exploits here, there's a user called admin and a user called hacker. We want user admin. Now the password, whatever. We're not going to need a password. But what I am going to need to do is throw in a truthy value here somehow, right? So let's get that and common name cn equals anything, right? It's whatever it is. That's not going to work. Percent zero null byte, and so it doesn't even matter what's after this, and we'll just leave the ampersand in there. I think. Let's give it a shot. Oh, unable to search. LDAP server message bad search filter. Okay, so I didn't do it quite right from memory. All right, looking at the notes. Where did I screw up? I'm not sure. Looks good to me. Must have typed in something wrong. Oh, percent. I forget the percent 00. Did I just type in 00? Oh, there we go. I forgot the double quotes here. So getting your syntax right, just like in software development, hacking and pen testing, gotta get your syntax right. There you go. Just using the kind of the value to fill in, like we could have done A star probably would have worked too. Yep, this was only the one A user. I don't know if there was a root user, but we could have done unauthenticated. Okay. I think there was just hacker, and we could do it with hacker too. Right? Don't need a password. That's LDAP. File upload. Good stuff. Good stuff here. File upload one. So if you can upload files, you can upload shells. And then you upload shells, you own the system. Just so you know. So in this case, we're going to browse. And I've already got some shells created. Some really simple ones. Just system commands. PHP system. So we're going to upload shell PHP. Send it. Your file can be found here. Well, of course. It's an error. We need to send something. There's ls. I could run cat password. We've got serious access at this point. And file upload example 2. In this case, I think the PHP extension was denied. A couple ways we could go about doing that. You could use htaccess. Upload htaccess to allow something like shell.hack to be interpreted as PHP. Or in this case, this is older. Newer nowadays, it would be like PHP 5, but this system's a little older, so it's PHP 3. You can use that extension, and it's going to get interpreted, and that's not being blocked. And it's pretty much the same thing at this point. Command equals. I'm getting tired of password. Let's yeah. That's the really common one. Right there, give you the info. And XML attacks. This is like my least knowledgeable area in pen testing and in hacking. So in this one, I definitely had to do some research to find out how to do it. XML. So example one, we're trying to basically inject. This is a variable in the XML interpreter. So the kind of example that we come up with using even the pen test, so the example one, there we go. So do something a little bit like this. They don't tell you where to put it, what to do with it. It's supposed to go before, so we put it in here, and then it gets executed here. So I'm going to show that and copy and paste it real quick. So we're sending this whole entire doc type. We're sending an entity with a variable. This variable is hackme. It's going to run. Oh, damn it. Time for me to wrap this up. And then I see system, file, etc. password. And then you can see here, ampersand hackme. That should call this variable. This isn't going to work. Excuse me once again. I'm not going to make it, am I? We got to URL encode that. We're going to get this giant block of encoding. There we go. And we've dropped the Etsy password again. And our final example, XML2. This one's pretty basic. We're just this is just taking the XPath expression. It's very similar to like using an SQL query. So we should be able to sort of do something like escape here with a single quote, or as a interpreted command. We're going to do 1 equals 1. It's our truthy value. And bracket, so that's where the XML will stop interpreting. And then just to keep anything else from interpreting, the null byte. Hacker admin. Boom. Okay. So what you see there is that we've got those two users, hacker and admin. If we want to take this a step further, I'm not going to explain this one specifically. But similar concept. In hacker, or 1 equals 1. There's our breaking, and then we're using these parent and child nodes. We've just dropped the users and their passwords. So that's all the examples and the, wait a minute, thought that was supposed to be web for Pentester. Yeah, somewhere along the line, bonus points, I went through and I defaced the website to let them know. And that is not a DOM. Here, I'm going to control F5. Oh, or I just closed it. Okay. What was it? 192.168. That's saved. Oh, you know what? I'll even double prove it to you. another client. So within one of these examples, I was able to go through there and fire off a defacing. I was able to just find and replace. I basically use sed, find and replace the text in the index.php. I could have done something more nefarious, like putting, a script that would drop malware in the headers of all the sites across all the pages across the entire site. That's how hackers do that. Instead, I just kind of left my tag. That's it. Thanks for watching, putting up with me getting all raspy in the last 20 minutes and barely getting through this. But if hopefully that helps with looking at web for Pentester. Time to press stop.